The third section in chapter 1 is titled Base and Derived Units of the SI. And what we discover in this section is that there are 7 base units that comprise the SI system. Let's look at those and talk about them just a little bit. The units that we're talking about here are bring this up so you can actually see it. Where are they? Right here we go. So these 7 base units are given here. There's the quantity, the unit, the symbol, and for SI we use for length we use the meter. For mass we use kilogram. For time, second. For electric current is ampere. Temperature is Kelvin. Luminous intensity is the candela, and the amount of substance is called the mole. You see the symbols given for those units over here in this third column. And I want you to pay particular attention to the symbols. Some are lowercase, some are uppercase. And it's important that you recognize the difference between those, because maybe a lowercase letter might mean a entirely different unit. So, make sure that you're familiar with the symbols that go along with that. Of course, ampere is something that we're very much concerned about in this class. Also, I would mention that temperature in Kelvin is not something that we're generally accustomed to. So we'll probably do some conversions to that when we're using temperature measurements. The second primary thing in this section is the discussion of what derived units are. And derived units express quantities such as area, power, force, magnetic flux, and so on. And there's really no limit to what these units are or how we can use them. And what they here they are mentioned or popped up here on the screen for us. And so, any combination of the base units can give us these derived units. Some of these derived units are used so much that they are given their own special name. He mentions one in particular, like the unit for pressure is the Newton per square meter. Okay, Newton is the base unit for force, and of course, meter is the base unit for length. And combining those two gives us a derived unit that we use so much. Instead of saying Newton per square meter, we have a special name for it called the Pascal. I'll point out a few others in this chart, like the farad, when we're talking about capacitance. Amount of charge is measured in coulombs. Electrical conductance, which is the inverse of resistance, is measured in Siemens. What else would we, of course, electrical potential, when we talk about volts, voltage. Electrical resistance is measured in ohms. A couple of others here, I won't read the whole list since you have them in front of you, but I would like to point out to you that in this class, I want you to get to the point to where you are familiar with the difference between energy and power. And a lot of people use those interchangeably. They are very different things. And by the time we get finished with this class, I hope you're comfortable in knowing what that difference is. Of course, we'll revisit that numerous times going forward. Let's see, anything else in this section that's of particular importance? I don't think so. Again, in this class, we haven't gotten there yet, but we certainly will. When we talk about electrical machines, magnetics is an important part of this. And in SI units, we'll be using the units of Webers to describe magnetic flux. And all of these at some point we will visit in some of our calculations and some of our interactions with these units.